All right, hello everyone. This is Ms. Pai. Obviously, we are starting the first video for our next unit. This unit is all about patterns. We're going to look at several different patterns that you'll see in math, and then we'll describe them mathematically with formulas. Okay, so when you are looking for patterns, there's three different types of patterns that you can have. The first one is an arithmetic pattern. And basically, that is a pattern that is created when you're adding or subtracting by the same amount every single time. So like if I count by twos, 2, 4, 6, 8, the pattern is arithmetic because I'm adding 2 to each number. Okay? Then there's a geometric pattern, and that's when you're multiplying or dividing by the same amount each time. Let's say our first term was 1, and our first term was 1. Well, 1 times 2 is 2. Our second term would be 2. And then we'd multiply 2 by 2, and we'd get 4. We'd multiply 4 by 2, and we'd get 8. Multiply 8 by 2, and 16, and so on. All right, and then the last category is just other. And so if it's not adding or subtracting every time, and it's not multiplying by the same number every time, then it's an other, okay? Now, other is, there's tons of different types of other patterns, okay? Think about the alphabet, A, B, C, D, E, F, G. That is a pattern, but it's not an arithmetic and it's not geometric, it's an alphabet, okay? There's lots of other patterns that we will see, and there's no hard, fast rule or formula for the other patterns. For the arithmetic and the geometric, we'll find very specific formulas to describe those patterns. All right, let me see. I think this is one of the last things we want to go over. Different definitions in terms and vocabulary words. So a sequence is just, let me delete that. It's just a list of numbers usually in a pattern. Okay, so 2, 4, 6, 8, that's a sequence of numbers. Your symbolism that you're going to use for that are brackets or commas. Notice here, whoops, I'm going to do that. Notice here I have these little sideways mustaches or brackets, okay? And I separate each term by a comma, okay? Now, when I say term, what the heck am I saying? I've used that word a lot. It's just a number in a sequence, okay? If I say, what is the third term? Well, in this sequence up here, the third term is 8. Okay, it's just in one of the numbers in the pattern. Okay, when you are figuring or annotating that, you're going to do a letter or variable with a subscript. Okay, that's something that we saw with our finance unit when we were doing the balance. We said B sub 0 was the initial balance. Okay. Remember that from our last week? B sub 0 is just our initial balance. Okay. And I think on one of the problems, I think it was equal to $1,000. So we said B sub 0 equaled 1,000. Okay. We're just saying that the first term was 1,000. All right, so what are we talking about when we get to positions? Is a term's ordinal location in the sequence. So first, second, third, fourth. Okay, that's what we're talking about. Usually in fact, in all of the problems in this unit, the N is going to represent which or the location of the term, first, second, third, or fourth. Okay, and so on. Now, recursion process of finding consecutive terms in a sequence based on a previous term. So When we are paying off a credit card bill, we needed to know the previous month's term before we could know this term, or the next term, okay? And let's see, what did I do with that? And, oh, okay, I know what I did. Down here, we have this pattern, or this example. We have a sub 1, our first term equal 2, and to find the next term, we're going to multiply our first term by 2. So in our pattern, we get 2, 4, 8, 16, 32, 64, 128, and then 256. So if we have a problem that has this situation, it tells us what is the 7th term, okay, we would just say it was 64 times 2, which is 128. Okay, when we're looking for the 8th term, we would say it's 128 times 2, or 256. All right, so that's recursive, using your previous term, doing the math to get the next term. Okay, now with explicit formulas, you've got this case. You have your a sub n. Let's say I'm looking for the 8th term. I would have 2 raised to the 8th power. Okay, and then in the calculator, I just calculate that out. Okay, this time I'm looking for a sub 10, so the 10th term in this pattern. So I'd have 2 raised to the 10th power, and I'd get 1024. If I was looking for the 14th term, I would have 2 raised to the 14th power, and I'd get 16,384. One thing that you're going to notice is when you are only looking for, like, maybe, let's say you only want to know the first 4 terms. It's really easy to do the recursive formula. But when you're looking for, like, the 10th term, or the 100th term, or the 1000th term, it would be a pain in the butt to find all the terms before that. Instead, it would be really easy to say, okay, so let's say we wanted to know a sub 100. So my 100th term, it's much easier to say 2 raised to the 100th pattern, or 100th power, instead of doing this huge recursive process 100 times to finally find my answer. All right. So I know this video was pretty long. Sorry about that. But we went over a lot of information. If you need to, go back, rewind, listen to it again so you know all the terms and vocabulary stuff, okay? It will help you tremendously, and it'll save us a lot of time in class, and we can actually look at some problems in class and work on them together.